So today's topic is graphical representation of non-ideal solution. According to our previous video, non-ideal solutions show positive or negative deviations from Raoult's law. So let us discuss first regarding graphical representation of non-ideal solution having positive deviation from Raoult's law. So this is a graph in which vapor pressure is plotting against the mole fraction for a liquid solution. Let us consider at this point x1 equal to 1 and x2 equal to 0. If x1 equal to 1, x2 obviously equal to 0 because x1 plus x2 always equal to 1. So at this point container is containing only pure component 1. So at this point we have vapor pressure for the pure component 1 only. Let us consider vapor pressure for the pure component 1 is P1 naught. For pure component, vapor pressure is denoted by naught. So this is the point at which x1 equal to 0 and x2 equal to how many? 1. If x1 equal to 0, then obviously x2 equal to 1. So at this point container is containing only component 2. Then at this point we have vapor pressure for the pure component 2 only. Let us consider vapor pressure for the pure component 2 is P2 naught. We are considering here vapor pressure for the pure component 2 is greater than the vapor pressure for the pure component 1. Now here dotted line represents the Raoult's law for an ideal solution. This is the dotted line. This is the dotted line which represents the Raoult's law for the component 1. On this line P1 equal to P1 naught x1, or this is for component 2. On this line P2 equal to P2 naught x2. But non-ideal solution shows either positive or negative deviation from Raoult's law. So for the positive deviation from Raoult's law, graph is like this. This is the curve. This is for component 2 and this is for component 1. So on this graph P1 is greater than P1 naught x1, and on this graph P2 greater than P2 naught x2, and this is the graph for the vapor pressure of solution. This is the graph for the vapor pressure of solution. So this is the graphical representation of non-ideal solution having positive deviation from Raoult's law. Dotted line represents here Raoult's law for ideal solution, and solid lines represents here non-ideal solution having positive deviation from Raoult's law. So regarding this graph, you can also follow the figure number 2.6 from the textbook. Now graphical representation of non-ideal solution having negative deviation from Raoult's law. Similarly, this is the graph in which vapor pressure of a liquid is plotting against the mole fraction. So in this graph also dotted line represents the Raoult's law for an ideal solution, but this solid lines represents the negative deviation, non-ideal solution having negative deviation from Raoult's law. On this line, on this curve, P1 less than P1 not x1, and on this curve, P2 less than P2 not x2. So in case of negative deviation, P2 less than P2 not x2 and P1 less than P1 not x1. So this is the graphical representation of non-ideal solution having negative deviation from Raoult's law. So one more topic, azeotropes. Some liquids form azeotropes. So what are the azeotropes? Azeotropes are binary mixer. Binary mixer means a mixer having two components. So azeotropes are binary mixer having the same composition. Having the same composition means concentration in the liquid and vapor phases, and boils at a constant temperature. So azeotropes बनाने के लिए मिनिमम 2 लिक्विड हम लोग मिक्स करना है. और एजियोट्रोप में क्या होता है, कंपोजिशन वेपर फेज एंड लिक्विड फेज दोनों फेज में कंपोजिशन क्या होता है, सेम होता है. और इन ए एजियोट्रोप both the liquid components are boiling at a constant temperature. एजियोट्रोप ऐसा एक लिक्विड लिक्विड मिक्सर है जहाँ दोनों लिक्विड 1 and liquid 2 both liquids are boiling at the same temperature. Normally different liquids have different boiling point, लेकिन जब एजियोट्रोप बनाने के लिए दो लिक्विड को मिक्स किया जाता है having a definite composition, then in an azeotrope both liquids are boiling at the same temperature. So in an azeotrope both the liquids are boiling at a constant temperature, therefore it is not possible to separate the liquid components by the method of fractional distillation. So fractional distillation, it is a method, it is used to separate liquid mixers. So azeotrope also a liquid mixer, but from an azeotrope two liquids cannot be separated by the method of fractional distillation. So from an azeotrope, why two liquids cannot be separated by the method of fractional distillation? Because in an azeotrope both liquids are boiling at the same temperature. Azeotropes are normally non-ideal solutions. So azeotropes are showing either positive or negative deviation from Raoult's law. So azeotropes are two types of azeotropes. Number 1, minimum boiling azeotropes. Minimum boiling azeotropes shows large positive deviations from Raoult's law. These are boiling at the lower temperature than the boiling points of pure liquid components. For example, 95% volume by volume, also known as by volume, of aqueous solution of ethanol is an example of minimum boiling azeotropes. So minimum boiling azeotropes shows large positive deviation from Raoult's law. So minimum boiling azeotrope shows positive deviation from Raoult's law. Azeotropes are non-ideal solutions. Non-ideal solutions are showing either positive or negative deviation from Raoult's law. So minimum boiling azeotrope is showing positive deviation from Raoult's law. And in a minimum boiling azeotrope is boiling at the lower temperature than the boiling point of pure liquid components. मिनिमम बॉइलिंग एजियोट्रोप ऐसा एजियोट्रोपिक मिक्सर है जिसका बॉइलिंग पॉइंट प्योर लिक्विड कंपोनेंट का बॉइलिंग पॉइंट से क्या होता है, कमती होता है. सेकेंड वन इज मैक्सिमम बॉइलिंग एजियोट्रोप्स. So large negative deviation from Raoult's law. These are boiling at the higher temperature than the boiling points of pure liquid components. For example, 68% W by W means by mass aqueous solution of nitric acid. So second one azeotropic mixture is maximum boiling azeotropes. So maximum boiling azeotropes show large negative deviation from Raoult's law. These are boiling at the higher temperature. Than the boiling points of pure liquid components. So maximum boiling azeotrope shows negative deviation from Raoult's law. और maximum boiling azeotrope का boiling point pure liquid component का boiling point से क्या होता है, ज़्यादा होता है. So example of a maximum boiling azeotrope is 68% biomass aqueous solution of nitric acid. So this is an example of maximum boiling azeotropes. So azeotropes are, what are the azeotropes? Azeotropes are binary mixture having the same composition in the liquid and vapor phase and boils at a constant temperature. So from an azeotrope, two liquid components cannot be separated by the method of fractional distillation, because in an azeotrope both liquid components are boiling at the same temperature. So azeotrope बनाने के लिए दो लिक्विड को मिक्स करना पड़ेगा और दोनों मिक्स करना पड़ेगा at a definite composition. So azeotropes are classified into how many types? Two types: minimum boiling azeotropes and maximum boiling azeotropes. Minimum boiling azeotrope is showing positive deviation from Raoult's law, and the maximum boiling azeotrope is showing negative deviation from Raoult's law. So this is about the azeotrope.